This video is going to walk through a good general strategy that can be used to graph any quadratic function. We're going to use this function f of x is equal to 2x squared plus 4x minus 1 as an example. Now, the first step, as we've talked about before, the vertex is just such a critical key piece of any parabola. So our first step is going to find the vertex. You remember we can use that general pattern that we know that the x value for the vertex is equal to the opposite of b or negative b over 2a. For us, our b is 4, so we're looking at negative 4, and our a is 2, so 2 times 2. So our x value for the vertex is going to be negative 1. All right, to find the y value, all we need to do is take that x value, negative 1, and substitute it into our function. So negative 1, so it's going to be 2 times negative 1 squared plus 4 times negative 1 minus 1, which is going to equal 2 minus 4 minus 1. Negative 2 minus 1 more is equal to negative 3. So fabulous. We know our vertex now is the point negative 1, negative 3. And we also have a little bit of an added piece of information that might be helpful, and that is we know the axis of symmetry is also x is equal to negative 1. Now that we know the vertex, the second step is to determine whether the parabola opens up or opens down. The clue for this is to look at the a value. And for this quadratic, our a value is 2. And this is really simple. If our a value is positive, the parabola is going to open up. If our a value happened to be negative, like negative 2, the parabola is going to open down. So for this case, since our a is positive, we know our parabola will open up. The next step is going to be to create a table of xy pairs. And these xy pairs are going to be points that we're going to be able to plot when we actually graph the parabola. Now, a good strategy to do this is we're going to use symmetry and patterns to make this as easy as possible. I'm going to start by putting the vertex, that's a point we already know, in the center of the table. And then I'm going to have two x values on either side of that vertex. So I'm also going to include 0 and 1. And going in the other direction from negative 1, I'll include negative 2 and negative 3. All right, let's use the function now to come up with the y values that go with each x value. I'm going to start here with 0. It's so easy to input 0. So f of 0 is going to be 2 times 0 squared plus 4 times 0 minus 1, which is 0 plus 0 minus 1, or negative 1. And I have a negative 1. Let's send 1 in next. Let's input 1, and we have 2 times 1 squared plus 4 times 1 minus 1, which is equal to 2 plus 4 minus 1, which is 5. Oops, which is 5. Now this next piece is so cool because we used points on either side of the vertex. We're going to use what we know about symmetry. Because we went plus 1 this direction and minus 1 that direction, the y value for negative 2 is also negative 1. Let's just double check that to make sure I'm telling you the truth. F of negative 2 is going to be 2 times negative 2 squared plus 4 times negative 2 minus 1. So that's going to be 2 times 4 minus 8 minus 1. 8 minus 8 minus 1 is, yes, indeed, negative 1. So that's super cool. We can use the same thing since I went plus 2 to get to 1 and minus 2 to get to negative 3. We can use symmetry to know that when we input negative 3 into this function, 5 also comes out. All right, so now we have a great table of 5 xy pairs. These are going to be 5 points that we're going to be able to graph with our parabola. All right, we have all the pieces we need now to actually plot the points and graph our parabola. So that's our last step here. I've already drawn my coordinate plane. Hopefully you're doing this on graph paper so that your increments are evenly spaced. I've made my graph nice and big and incremented by ones in all directions. All right, I'm going to start by plotting my points. And again, I'm going to use symmetry as much as possible and start by plotting my vertex, -1, -3. If you want, it's also can be helpful to sometimes just draw a little dashed line if you want to show that axis of symmetry, to remember that everything about the parabola is going to be symmetrical across that line. All right, let's next plot 0, -1, 0, -1, and the mirror point, -2, -1, -2, -1. So as you plot a point and its mirror point, or a point and its symmetric point, it just makes your graphing so much easier. Next, let's do 1, 5, 1, 5, and its mirror point, -3, 5. All right, I have plotted my 5 points, and now I'm going to draw the curve of the parabola as smoothly as possible. Of course, it's never going to be perfect, but we're going to get that good general idea of what the graph of the parabola is.